Hello, today I'm going to be showing you how to complete the third disk mover activity. As said here, we must use the electromagnet to pick up and place one disk of each color inside each colored goal. Also, each goal should have one green, one red, and one blue disk to complete this challenge. Let's go back to VexCode VR and look at the disk mover playground. As you can see here, there are 3 lanes, one blue, one red, and one green. The goal is to drive forward, pick up a disc, then drive back to the square and place it, as well as drive forward, pick up a disc, and place one in each of the other colored squares. I started out by making a simple drive block. This will drive forward until the down-facing sensor sees a disc. When it detects the robot is over a disc, it will stop driving. Then I made a block that tells the robot to drive back to the original square. I made sure the robot was facing forward, then told it to drive backwards until it was at -800. This is the Y coordinate, which is right in the center of the squares. After I finished those steps, I compiled them into a single disk pickup block. It drives the robot forward to the disk, then picks it up using the electromagnet. Finally, it drives backwards until it is in the original square. You may notice that I did not drop the disk yet, but I will do that later. This is because we have to drive to other squares before dropping the disk. The next block I made was the drop disk block. While coding, I realized that the robot would end up skipping steps without this. I found the problem was that it sensed disks that it had already placed, making the bot think it had already picked up a disk. To fix this, I made a block which drives the robot backwards a short distance, drops the disk, then drives forward. It prevents the robot from seeing the disks after they are dropped. After that, I made some blocks that tell the robot how to move to the boxes. When the block starts out, it first tells the robot to drive to -800Y, which is the starting point of the program. It does this to avoid the walls while going to the other colors. Next, the robot turns toward the designated square. In this block, I set the turn heading to 270 degrees because the robot must be facing left to reach the blue square. Next, I made a repeat statement that told the robot when it was in the correct square. Instead of using the color sensor, for example this down-eyed detects red sensor block, I used distance. Because of how the virtual robot moves, I could not just have position x in millimeters, in this case equal to -800. I needed to use a less than statement so the robot would stop in time. Finally, I told the robot to stop driving and drop the disk. It is the same with the block that drives to the green box, except the statement is greater than instead of less than, and the coordinate is set to the center of the green box, 800 instead of -800. Coding the robot to go to the red square was slightly different from the rest. Because it was in the middle, and equal statements do not work all the time, I needed to make 2 separate blocks. One of them drove the bot from the blue box on the right side of the red box, and one of them drove it from the green box, which is on the red box's left side. They are the same as the last 2, except for being split into 2 blocks. Now that I completed all of my blocks, it was time to code the robot so that it would be able to complete the program. To do this, I made 4 new blocks, all making up one major part of the program. The first one picked up and dropped all of the blue disks, the second one picked up and dropped all of the red disks, and the third one picked up and dropped the green disks. When I was originally making this program, I realized that each block started with the same 3 blocks. Because of this, I shortened the beginning of each section into one block, to make the program more compact. This first step block runs pick up disk, drop disk, and pick up disk again. It picks up the first disk in each row and places it in its colored box. Then it picks up the next disk in each row and moves on to the rest of the code. For blue, you can see that it goes to the red box, drops the disk, goes back to the blue box, and so on. It is similar with the green box, except it goes to red and blue. But the red box's block is different. Because I did not end the previous green block in the red box, I need to go to the red box at the start of the program. Because the red box was in the middle, I need to use the two different go to blocks so the robot will know exactly where to go. The last thing I needed to do was place all the blocks under the when started block. So the first thing that I put under it was the set drive velocity to 200. Normally, the drive velocity and turn velocity are set to 50%, so I set them to 200%, which makes the program run much faster. Then I put in all blue disks, all red disks, and all green disks. Now that we've completed the program, I'm going to run it so you can see what it looks like when it's finished. Thank you so much for watching my tutorial. If you need any help, feel free to send me an email using the link in the description. Bye!